Okay, today we are going to start with the continuation of the integration. That is, actually, this is the one part of the applications of integration, that is solving differential equations. Differential equations. That's a fact we are going to discuss about today, right? Okay. Then, yeah, we'll start with this kind of approach. So anyway, like if we have a differential equation somewhere like this, dy by dx, it might be a function of fx into gx, because you know that all the differential equations are not only with x variable, there may be some differential equations in form of x and y both. So in this case, initially what you can get here is that making, you have to isolate fx and gx separately. So you can just work out, if you happen to see a function like this, 1 over, sorry, gy, not gx. There are two different variable equations. 1 over gy dy is equals to fx into gx, if fx into dx, right? That means, so when you're doing a question, you'll understand what I mean over here. Then what you need to do is we can integrate the both sides. 1 over gy dy is equals to, when you take it into fx dx. That's the simplest idea of doing this. So anyway, it doesn't make a difference. 1 over gy means anyway it's a function. So we will work accordingly and to obtain the answer for this. Right. Let's see from a question what kind of situations they were requesting us to do it. Right. For example, just like this, they have given dy by dx is equals to x over y, x over y, and the curve y passes through 1 minus 2. They ask about find y equals to fx. Y equals to fx means you have to find y in form of function of x. That's what they expect you ask for us to get it today, right? Let's go ahead with this today. Initially, what you need to do is you have to keep this dy by and dx in one side and take x variables to one side and y variables to another side apart with the dy by dx today. So you can write y dy is equals to x dx. This is pretty simple. So we just isolated dy and dx. So anyway, when you're doing this isolation, this dy and dx should be come to the numerator. Then the next step, you can integrate them separately. Y dy is equals to integration of x dx. Then what you can get here is that if you integrate it, it's turn up to y squared over 2 is equals to x squared over 2 plus c. Then divide both sides by 2, then turn up to y squared is equals to x squared plus, me come just again we can put it as c. Now we need to find the value for c. But how to find the value for c? We know that it passing through 1 minus 2. That means minus 2 squared is equals to 1 squared plus c. Therefore, it turn up to c is equals to 4. It's 3. Then you can say y squared is equals to x squared plus 3 would be the final answer for this kind of a question. Okay, simply you can get this answer. Yeah, let's go ahead with another question. Yeah, 1 plus x squared dy by dx is equals to x tan y. X tan y, right? Then what you can get here is that bring this, what do you call that, y terms to one side and x terms to other side. Anyway, when you take them up, dx should be come to the numerator. That's why you can say x over 1 plus x squared. And this is turn up to dy 1 over tan y. Then we know that 1 over tan y is equals to cot y cot y dy is equals to x over 1 plus x squared dx. Then you can integrate the both sides with it. We know that cot y integration, the cot y integration is ln sine y. You should remember these integration formats. Sine y is equals to here with a so if there's a fraction, I told you in last session, if you have a fraction, see whether the differentiation of this is available here. Yes, you can make it by just doing a small change over here. So I just make it, I just do it here, x 1 plus x squared. Anyway, if you differentiate it, 2x should be generated in the numerator. Therefore, you can put a 2 here and you can put a half outside. With that, you can write this is 1 over 2 ln 1 plus x squared. In this kind of situation, for the convenience of the calculation, we write the constant term also in terms of ln. The purpose is if all the terms are in ln, just write the constant also in terms of ln. That makes you much easier for us to do this. So question, I just added some kind of a boundary condition also here. That is, yeah, so it can turn up to 2 and pi by 4. Right, okay. Then let's go ahead with this.
Sir,
Yeah. Yes, what is it? Can
sir, how did half come?
how do you?
A half because 2 is there, no? Okay, sir.
Two is there, yeah, that's it. So it's turn up to ln sine y equals to, from here, you can take this half in. 1 plus x squared, half you take it means square root, it turn up to square root into c. Then you can say move this ln and ln to both sides. So you can say sine y is equals to 1 plus x squared, the square root of it plus, sorry, into c, into c. Then what you can get here is you can substitute the boundary conditions. But the boundary conditions 2 pi by 4. So you can say sine pi by 4 equals to square root of 1 plus 2 squared into c. So it's turn out to the sine pi by 4 is how much? 1 over root 2 and this is the root 5 into c. Then c is equals to 1 over root 10. Then you can write the final answer. Sine y is equals to root 10 times of square root of 1 plus x. Square don't make simplify one. Sine y equals to square root of 10 times of 1 plus x squared. If they ask you to subject y, you can write this is sine inverse. It depends on the question they ask, but they 10 into 1 plus x squared is meet the square root of it. Sorry. It depends on the way they request you to write the question. I just put the full question at once. So then you can see the question. Yeah, that's it. That's a way of asking this kind of a question. Right, let's go ahead with another situation. It is they give dy by dx is equals to minus dy minus 2 divided by 2x plus 1 x plus 2 x plus 2, right? Okay. Now let's go ahead with this question today. So initially what you need to do is we have to bring this y term to one side while keeping dy and dx at the numerator. That is the important point. Right? Then I can put 1 over, this is y minus 2 and this is minus 3 over 2x plus 1 and x plus 2. Right, okay. Then what you need to do is put the main part and then after that you can do the integration for both sides. So this part of integration you can do it pretty simple. What is it? To make up it. This is just like straightforward the differentiation. This is 1 over here. This part you can write y minus 2. It's not a problem over here. But the problem is this bit of it. Here there's a fraction where the denominator is, the differentiation of the denominator is not available in the numerator. Therefore, you have to go into the partial fractions. Therefore, I'm just going to do that. And finally, I just add this into the calculation. If you come across any doubt, please ask how it comes. Then I'm going to find the value for a by making x, this part 0, minus 1 over 2, that is minus 3 equals to minus 1 over 2 plus 1 is 3 over 2. Therefore, you can say a equals to minus 2. Then I'm going to find the value for b by making this is 0, minus 2. So it's turned to minus 3 equals to minus 4. It's minus 3 b, sorry. B, therefore, b equals to 1. Right. Then what you can get here is, okay, then what you can get here is, but then you can write this integration this way, minus 2 over 2x plus 1 plus 1 over x plus 2. Now you can see the differentiation of this is 2. Its minus is there, but you can write this minus ln 2x plus 1. So nothing to add over here. Only thing to take this minus 1 out plus ln x plus 2. Since all the terms are in ln, I'll just write the constant also in terms of ln. See, just then you can get it. But then you can say ln y minus 2 is equals to, here you can write this is ln x plus 2 here, and this is a negative, therefore into c divide by, you can put this value over here, the 2x plus 1. Right. Then you can write y minus 2 equals to c times of x plus 2 divided by 2x plus 1. So let's see whether they have given the boundary condition. No. Yeah, x equals to 1 and y equals to 4. In this question, they give us x equals to 1 and y equals to 4. It's given the coordinate 1, 4. And you can find the value for c over here. Yeah, then c is equals to 2. Then you can write your final answer in this format. You can say y is equals to 2 times of x plus 2 over 2x plus 1 plus 2. It's the final answer for that. But then just see whether can you understand how I did this question. But yeah, that's a way of doing this kind of a question. Yeah, that's how it comes. So now you can do all the general equations in form of that. So that's the way of doing it with it. Right, okay. I think you can do it. Then you can go ahead with exercise 6F and see whether you have any kind of hard questions where you're still feeling doubtful how to do these things, right?
Sir, you're mute.
Okay, here. The water manufacturing plant has a tank of diameter 20 meters, therefore the radius is 10. You have to keep it in mind. Water flows out of bottom of a tank through the tap with the proportional to the cubic root of volume. Rate of change of volume. That means how fast the volume changes is what you mean by the leaking or whatever the thing it's pouring to the water or leaking, whatever the fact you can mention by dv by dt. The mention is proportional, therefore you can put a k times of cubic root of volume. It's not square root, actually it's a cubic root. This way, show that t minutes after the dh over dt. Dh over dt means what? The rate of change of height, right? Then how to form this equation? We know that volume is pi r squared h of a cylinder. Then r is 10, therefore it's turned up to pi into 10 squared into 10 squared into h, so it's turned up to 100 pi h. From this information, we can find dv by dh, that is 100 pi. Then apart from that, they have given rate of change of volume is cubic root of V. So instead of K, they have put C here. Minus, because why we put minus? Because we know that it's a leaking. Volume is reducing. To represent it, we just put a minus over here. Then C cube into V. Then we know that V is 100 pi, we already found from here. Then if you replace, and we need expression for dH over dt. Then you can write this is dH over dt, and rest of the fact we can fill up with the available variable V. Then you can say dH over dV. We know that dV by dH is 100 pi. Therefore, dH over dV become 1 over 100 pi into dV by dt. dV by dt is this bit. Then the fact here is, we know that here the variables are t and h. Then all other facts are constant. So if you simplify, instead of all of these things at once, you can put just a single constant. And it's because like while keeping these ones, it would be kind of complex. Therefore, instead of all of these things, I just assign some kind of single constant, because it's not a problem at all. Later on we assign it, because we haven't assigned any figure for this. Therefore, instead of all these constant, we can put just a single constant. Then this is the equation, right? Okay, then that's how it comes. Then they mention, show that the general solution of the differential equation can be written by this format, right? Let's go ahead with this. Then we know that here, the fact where we have is dH over dt is equals to minus k times of h to the power 1 over 3. Then you can write h variables to one side. So you can put minus k dt is equals to 1 over h to the power 1 over 3 dh. Then what you need to do is integrate both sides. If you integrate both sides, what you get is h power minus 1 over 3, h to the power 2 over 3 over 2 over 3 is equals to minus kt. Then you can write this is 3 over 2, h to the power 2 over 3 is equals to minus kt plus c. Right. Then how do you suppose to do this? Then you can take this h. You have to find some kind of expression for h to give, because we need the expression for h. So h is subjected over here. That's what in that expression what they have given is. So I can write h to the power 2 over 3 is equals to minus 2k over 3t plus 2c over 3. So instead of this, again I can put another constant. Constants, because k is still we haven't decide any kind of constants. Therefore you can write h to the power 2 over 3 is equals to minus qt plus p k. Then you can write h is equals to minus, you can, if you want, you can take this minus out and you can write it p minus qt whole thing to the power 3 over 2. That's a way of getting this, right? That's a simple way of forming this equation. Okay. Then what they want is, initially the height of water is 27 meters. That when method may fact initially height of water is 27. You can when t equals to 0, h equals to 27. 10 minutes later, when t equals to 10, h become 8. Then you can replace these figures into this equation and you can obtain the value for p and q. You can get these answers and you can find the value for p and q. That's what they have given. The last part is find in terms of minutes when the water is depth is 1 meter. So what you need to do is after that, after forming this P and Q, it's already given here. Then yeah, yes, over here it's the, so with that you can get the equation H equals to P is 9 minus Q. Q is 1 over 2 1 over 2 t whole thing to the power 3 over 2. Then honey, find the time where the h is 1 meter. So you can replace 1 over here and you can obtain the value for t. So that is a way of formulating this kind of an equation.